Pre-calculus 7.4, day 3. We are going to be doing partial fractions, but we're not going to give you the setup. You have to figure out the setup and then follow the process that we did on day 2. So the first step is to factor the denominator so we know how to break it up. So we have this x squared plus 6x plus 8, and that factors into x plus 2, x plus 4. And so then, since x plus 2 and x plus 4 are linear factors, we're going to use a over x plus 2 and then b over x plus 4. Note that since you are creating this, you might put a over x plus 4 and b over x plus 2. That's not a problem. It's just we'll switch them at the end and we'll have the same answer. So anyways, now clear the equation of the denominator by multiplying by the LCD, which is x plus 2, x plus 4 on each term. And we get x plus 8 equals a times x plus 4 plus b times x plus 2. And then you have two methods. You can expand and equate coefficients, or you can use convenient values. I am going to expand and equate coefficients. So we get x plus 8 is ax plus 4a plus bx plus 2b. And then if I move the terms with x next to each other, and then the constants to the right, I can factor out the x. And so now, the coefficient of x on the left has to equal the coefficient of x on the right. And the constant on the right, oops, that didn't work. There we go. The constant on the right needs to equal the constant on the left. So then I set up the system. A plus b has to equal 1, and 4a plus 2b has to equal 8. And then solve that however you want. If I solve the top one for a and I get 1 minus b and substitute that in for a in the second equation, and just solve, I'm going to get 4 minus 2b equals 8. A negative 2b equals 4, and b is a negative 2. And then a is 1 minus b, so 1 minus a negative 2 is 3. So you need to, in this case, come back and finish up, and your a is over x plus 2, and the b is over x plus 4. And that's just fine. You need to come back to this as your final answer. It is no longer, you can say a is this and b is this, because it depends on how we set it up. By the way, that is the same as 3 over x plus 2 minus a positive 2 over x plus 4. So you could have either of those your answer. All right, example 2. Again, we need to factor the denominator. And when I factor that denominator, I take out an x, and then I am left with x squared plus 9. And so x is a linear function, so I'll put a over it, but x squared plus 9 is of degree 2, so I have to do a linear factor on top. I have to use bx plus c, and that's how we'll set that up. Now, as I multiply both sides, every term by the overall LCD, and clear out those fractions, this is what I'm ending up with. I am again going to expand and equate coefficients. And then I'm going to move my x squared terms together. And then it'll be my terms with x and then my constant. And so on that right-hand side, if I factor out the x squared, it looks like this. And then I just have cx plus 9a. So my 5 has to equal a plus b because those are the coefficients of x squared. And my -1 has to equal c because those are the coefficients of x. And then let's see, my 27 has to equal 9a because those are my constants. So when I set up my system, I get a plus b is 5. I know that c is a -1 and that 9a has to equal 27. And so I can solve the last one for a by dividing by 9, and I get a is 3. We know that c is -1, and then I can substitute a into a plus b equals 5 to get the value of b, which is 2. Now you have to finish this up by replacing a, b, and c into the equation. You don't get to just state a, b, and c like we did on the last assignment because it wasn't set up in advance, so we could have different setups. So you have to actually come to write 3 over x plus 2x minus 1 all over x squared plus 9. And that is